Bees are amazing animals that are essential to our environment. In addition to making honey and beeswax, they aid in pollinating plants and vegetables, which is crucial for preserving the environment's health. Bees are renowned for their excruciating stings, despite the fact that they have many beneficial qualities. The fact that the bee dies after stinging is what distinguishes bee stings, which begs the question of why bees die after stinging. But if you haven't subscribed to the channel, please subscribe to our channel and press the bell icon to never miss an update. It's critical to examine the structure of a bee bite in more detail to comprehend why bees perish after striking. A hooked stinger is affixed to the thorax of bees. The stinger is an altered version of the ovipositor, or egg-laying tube, that female bees use to deposit eggs in the honeycomb cells. A bee stings by driving its stinger into the victim's epidermis and injecting poison through it. Pain, swelling, and other signs may be brought on by the complicated combination of proteins and enzymes that makes up the venom. The stinger's barbs are intended to pierce the victim's flesh and keep the bee from being able to remove its venom. This design keeps the bee's stinger in the victim's skin so that it can continue to produce poison even after the bee has flown away, which is useful for defending the colony. The stinger's barbs are angled so that while they enable the stinger to pierce the epidermis, they also make it challenging to remove. The barbs on the bee's wings snag on the victim's skin as it attempts to fly away, drawing the stinger from the bee's abdomen and embedding it in the victim's skin. The impact of a bee sting on a victim. A bee sting causes pain, swelling, and redness by injecting venom under the victim's skin. The person's sensitivity to the venom and the number of stings determine how severe the symptoms are. Anaphylaxis, a serious allergic response that can be life-threatening, can occasionally be brought on by bee stings. The venom sac continues to pump poison into the victim's body when the stinger is left in the victim's epidermis, which can exacerbate the sting symptoms. A range of compounds in the venom are meant to defend the beehive from predators and other dangers. These substances may trigger an immunological reaction in the body of the sufferer, resulting in discomfort, edema, and inflammation. The impact of a bee sting on a bee stings are not intended to cause damage to the sufferer. Instead, the bee is defending its community or hive. The stinger and poison reservoir of the bee, however, are attached to its musculature and digestive system. The bee's interior systems, such as its digestive system, muscles, and heart, suffer severe harm when the stinger is ripped from the bee's abdomen. The venom sac keeps pumping poison into the victim's epidermis, which can make the sting's effects worse. The bee loses a substantial quantity of venom as a result of this continuous venom release, which may impair its ability to protect the colony in the future. In addition, the bee may find it challenging to travel and search for sustenance if its stinger and poison sac are lost. Bee stings are not intended to cause damage to the sufferer. Instead, the bee is defending its community or hive. The bee's stinger and venom sac, however, are attached to its muscles and digestive system. As a result, when the bee stings someone, the stinger gets stuck in their skin and is torn from the bee's abdomen, seriously injuring the bee's internal organs. The venom sac keeps pumping poison into the victim's epidermis, which can make the sting's effects worse. The bee loses a substantial quantity of venom as a result of this continuous venom release, which may impair its ability to protect the colony in the future. In addition, the bee may find it challenging to travel and search for sustenance if its stinger and poison sac are lost. Given that worker bees are replaceable and are readily replaced by the queen bee, the loss of a single bee may not have a major effect on the colony, the productivity of the swarm, and the longevity of the colony, however, may be significantly impacted by the deaths of numerous bees. A pheromone that a worker bee emits when it strikes alerts other bees in the hive that there is a danger. In order to defend the colony, the other bees then become more hostile and may even start to strike. Multiple bees may perish as a result of a mass assault on the perceived danger as a result of this. Additionally, when a bee passes away, it exudes warning pheromones that alert other bees in the hive that a danger exists. More bees may sting and die as a consequence of the colony's possible protective reaction. The capacity of the hive to gather food and care for the young can also be impacted by bees dying from stings. Worker bees are in charge of gathering nectar and pollen, taking care of the young, and keeping the hive in order. When worker bees pass away, the colony might not be able to gather enough sustenance or properly care for the young, which can reduce the hive's output and chances of survival. Because it developed as a defense strategy against more powerful enemies, bees have barbed stingers. The barbs on the stinger become embedded in the epidermis of the attacker after a bee strikes a mammal or avian, making it difficult for the bee to be dragged away and enabling the poison to continue to be administered. An adaptation that makes the bee's stinger more effective at defending its nest or population is the presence of barbs. It is more likely that the predator will be discouraged from assaulting the swarm or colony in the future thanks to the barb's assistance in anchoring the stinger in the prey's skin and enabling the bee to inject more venom. However, the bee itself suffers a serious disadvantage as a result of this evolution. When a bee strikes a person or another animal, the barbed stinger becomes embedded in the victim's epidermis, and the attacker pulls the bee's body away as it attempts to extract the stinger. The insect dies as a result of the thorax being torn. It is important to remember that not every insect has sharp stingers. For instance, while some species of bees, like carpenter bees, had smooth stingers that can be removed without causing much harm to the bee's body, others, like honeybees, bumblebees, and stingless bees, have jagged stingers. The bee's stinger is an egg-laying tube that has been changed to be used as a tool of defense. The stinger penetrates the victim's epidermis and into the flesh where the bee strikes them. Because the stinger is barbed, it sticks into the epidermis and is difficult to remove. The stinger is torn from the bee's abdomen as it attempts to fly away, seriously injuring its internal systems and ultimately killing it. Male bees cannot strike because they lack stingers, so they do not perish when they assault. Although female worker bees have stingers, they are made more for defense than for attacking. Typically, worker bees won't sting unless they feel intimidated or think the hive is in danger. A worker bee's sting sends out pheromones that warn other bees of peril, and they may decide to join the assault. A bee dying after being stung is not a deliberate act. Rather, it is a result of the bee's anatomy and behavior. The stinger and venom sac of the bee are crucial defense mechanisms for the hive, but they come at a high expense to the individual bee, given that worker bees are replaceable and are readily replaced by the queen bee. The loss of a single bee may not have a major effect on the colony. In conclusion, the shape of bees' stingers and the barbs that hook into the victim's skin, stopping the bee from removing it, are the causes of bees dying after striking. Diverse compounds found in the venom that bees inject are meant to defend the hive from predators or other dangers. But they can also hurt people and other animals and cause allergic responses. It's vital to keep in mind that bees are crucial pollinators, so whenever feasible, we should try to prevent upsetting or provoking their colonies. That's it for today's video. Hope you find the video interesting, and if you did, please like and share the video.